So in this short video of our introduction to coding with R, we're going to cover data frames as a way of looking at tabular data. So previously we looked at the logistics, why we want to code with R, or for data management, how to use the R interface, how to install, swirl, variables, vectors, and operators, and now we're moving on to more complex data types known as data frames. So data frames are a type of table. So typically we would be reading in CSV data as a table. So typically in a CSV file, the first line, only the first line, contains names of variables separated by commas. Tabs, if you have TSV, tab separated data can also work as well. The variables should be proper numbers or plain text, but no spaces, 20 characters, or punctuation marks. The data may be a mix of numbers or grouping variables, so like ones and zeros, but try to keep them numerical rather than using labels. Time sequences will be okay with in R. Times and dates may be problematic. If you have missing data, they should be represented by the letters N and A for to denote that they are not known and nothing else. So no dashes, no 999, 777, or any weird characters. Just use NA for missing data in R. So data frame is a table or a spreadsheet. We have the variables along the columns and the samples along the rows. So you might have a range of different treatments and then a range of different mice that you're looking at, and they'll be along the rows. And the features of those mice will be the columns or treatments. So each has a different rows column specific observation, and that's typically numerical value that will be recorded there. And that means in R, you'll be able to select a particular row or column as a vector. So think of a data frames as a set of vectors. An example of a simple data frame in R is the iris data set that we'll use a few times. So from iris, we can select the columns the first 5 rows. So the first when we're looking at data frames, we have a square brackets to subselect the parts that we want, like vectors, but there's 2 entries because each data frame is like a big matrix. So we can subselect element 1, 1, 1, 2, 1, 3, 1, 4, and so on. So this first parameter indicates the rows that we want. And the second part here, which is empty, because we're selecting all the columns, all the 5 columns that are present, you can see that we find out about the irises. These are flowers. They're the several lengths, the several widths, the petal lengths, the petal widths, and then the species, the different species that's associated with them. You can see here that if we look at the columns, we're selecting columns 1 and 2 here. We can select those individually here. And in the same way, we can identify individual cells if you want. So think of it this way. We have our columns here, like people, pieces, and likes. And they've got the rows here recorded as 1, 2, 3. And these entries are our data. So the data frames use this function data.frame with an argument sent in the middle containing our data we want to look at. This is like an ordered list where the entries correspond to each other, and each element of the list has the same length. So for example, we can create a data frame by saying that maybe H is heights here. We can concatenate 5 heights together in this order, and maybe W is weights, and we can have 5 weights together in this order. And if, say, entry 1 in each of these correspond to each other, and same for entry 2 and 3 and so on, like a proper table, we can combine these together using the function data frame and just say weights is equal to W and heights is equal to H. And maybe we can call that patient data. And if we ask what patient data looks like, at the end, we'll see this. So it's an ordered table containing the rows 1, 2, 3, 4, 5, contain the heights and weights. So we can access individual heights and weights within there and say, maybe what is the weight of patient 2. And we can use that using the row column setup we had before. So we have these, comma 1 corresponds to column 1, comma 2 is column 2, comma 3 is column 4, and so on through all the different columns that you have. And the same for the rows, they're just the first element. 1 comma is the first row, and all the entries in that first row. So if we ask this from OR, it will give us that full vector of all of the information in row 1. And it's the same for row 2, row 3 is the same. And we can ask ourselves what's in row 1, column 2, and that will return this particular value. So we can use Dataframes as a flexible way of obtaining information about our data set of interest. So that concludes this 7th video in our course on learning to code with R.